If global emissions are not drastically cut by 2030, we lock ourselves into a trajectory where the Earth heats up by nearly 3 degrees Celsius. This isn't a distant projection, it's a mathematical limit we are approaching by the end of the century. The physical evidence of this heating is already visible in the Alps. When the permafrost holding the mountains together thaws, it triggers disasters like the Bondo rockfall. 3 million cubic meters of rock crashed here, obliterating homes and reshaping the landscape. Glaciers retreat by meters every year. In these comparison shots, you can see how the thick white ice has been replaced by exposed rock. In just a few decades, these massive natural features could be gone entirely. These tragedies in the Alps indicate a much larger shift. The frozen structures that have remained stable for thousands of years are now losing their structural integrity. In Siberia, this collapse is even more literal. As permafrost thaws to twice its former depth, the ground itself gives way, creating massive megacraters like the Bottigiega. These depressions reveal soil that has been frozen for 40,000 years. Thawing soil is a biological threat. Microbes convert ancient biomass into massive amounts of carbon dioxide and methane, creating a feedback loop. To stop this carbon bomb, we must eliminate 30 gigatons of emissions by 2030, an enormous empty ledger we need to fill. Eliminating 30 gigatons in 10 years is a massive challenge, but researchers have developed a 3-step mathematical blueprint to systematically erase this carbon debt. Step 1 is the most direct. By phasing out coal and expanding current renewable technologies, we can shave off the first 3.7 gigatons of emissions. Norway's Tonstad hydroelectric facility is a model for this expansion. It uses the country's vast water reservoirs to generate enough clean energy for a city of 1.5 million people. This surplus energy doesn't just stay in Norway. Through the NordLink subsea cable, this power can be exported to Germany whenever wind speeds are low, ensuring a steady supply of green energy across borders. This shows that the initial phase of the blueprint relies on existing technology. We can make significant progress simply by connecting the green infrastructure that is already built. Step 2 is the most aggressive part of the plan. It requires a 12 gigaton cut, achieved by scaling next-generation technologies and halting global deforestation. One example of this is high-altitude wind engineering. Systems like the Skystale's kites can reach 700 meters above the ground, where wind is faster and more consistent. At that height, they can harvest double the wind speed, leading to 8 times the energy yield of a standard turbine. This high-tech approach is paired with massive ecological restoration. In Sudan, projects are planting millions of acacia trees in regions that were becoming desert. These trees drive their roots deep into the ground to reach water, stabilizing the soil. This prevents desertification while allowing local communities to harvest gum arabic, creating a sustainable income from the restored land. This phase of the blueprint succeeds by combining engineering from the global north with community-led restoration in the global south. Step 3 targets 3.3 gigatons in sectors that have historically been the hardest to change: heavy industry, building maintenance, and agriculture. A major part of this step involves agricultural emissions. If meat consumption were reduced to about a quarter of current levels, roughly 300 grams per week, the associated methane and land use emissions would drop significantly. In our cities, we can use passive solutions. Researchers at Aachen University have developed textile facades that block the sun's rays. These fabrics can cut the energy required to cool a building by more than 60%. While the previous steps used machines and trees, hitting this final tier requires us to adjust how we design our cities and how we choose to eat. When we total the steps, we reach a massive 20 gigaton reduction, but it leaves a 10 gigaton gap. This cut misses the 1.5 degree target, but caps warming at 1.8 degrees, preventing the most extreme scenarios predicted for a 3-degree world. To address the remaining 10 gigatons, we must move beyond reducing emissions and start actively removing carbon from the atmosphere, using carbon capture and storage. Norway's Northern Lights project is already testing this at scale. Liquid CO2 from across Europe is shipped to this terminal, and then it is pumped 2,600 meters deep into subterranean sandstone under the North Sea, where it can be stored permanently. From underwater hydro cables and high-altitude kites to deep-sea carbon storage, the tools to meet these targets are already in operation. While the scale of the 30 gigaton ledger is immense, These incredible projects clearly demonstrate that we already possess the technical and ecological systems required